Hello and welcome to this online lecture about balancing equations. So when chemical reactions occur, we have to obey what's called the law, oops, my W got away from me there, law of conservation of matter. And that's a V. Basically, what the law of conservation of matter says is that in a normal chemical reaction, matter can't be created or destroyed. So that means that whenever any chemical reaction happens, you're never making new atoms, and you're never taking atoms that exist and just getting rid of them, just destroying them. So because of the law of conservation of matter, because that's something that happens in our universe, we have to remember that when we're trying to write down an equation, we have to make sure that our equation is not creating or destroying any matter. Because if it is creating or destroying matter, atoms, then it's going in direct it's going directly against the law of conservation of matter. So let's take a look at what the heck we're talking about here. We'll use the equation for the synthesis of water. Hydrogen plus oxygen makes water. By the way, we've talked about this offhandedly in other lectures. Remember, there are some elements that whenever they're by themselves, whenever they're just that element, they always form molecules. The atoms always bond in pairs to form molecules, and they're called diatomic elements, and hydrogen and oxygen are diatomic elements. So make sure that you're aware of that and that you are always keeping that in mind when you're trying to write equations. So this equation has H2, we'll make the H's be blue. So there's H2, we'll make the oxygens be orange. O2, and then it makes H2O, which would then look like this. Now, if you look at this carefully and you think about what I just explained to you about the law of conservation of matter, you see that you've got two hydrogen atoms over here and you have two hydrogen atoms over here, so that's good. But you have two oxygen atoms on the left side of the reaction before the reaction happens, and you only have one oxygen atom at the end of the reaction. So matter cannot be created or destroyed. If this equation happens, if this reaction happens exactly as it's written in this equation, you're destroying an oxygen atom. See, like you're just saying, okay, this oxygen atom is just gone. And that is not okay. You can't have that. And so how do you fix that? Well, you do something that's called balancing equations. So let's go back to our equation. I'm going to write it, space it out a little bit. I'm going to write it again. We have H2, we have O2, and those are the reactants. The compounds on the left of the chemical equation are the reactants, or the compounds you have when the equation starts are the reactants. And then that's making H2O. I just realized I wrote my O2 in the H2 color. Okay, so we've got H2 plus O2 making H2O. And the problem here is that we don't have the same number of each atom on each side of the equation. And so what I usually encourage students to do is make like a little table. Hydrogen and oxygen are the two atoms that are in this compound, and then you use this little table to count. So on the reactants side of the equation, there are two hydrogen atoms and there are two oxygen atoms. And on the product side of the equation, there are two, oops, gotta get the right color, two hydrogen atoms, and there is one oxygen atom. And so basically what we're doing here is it's kind of like almost like accounting. We're going to make sure, we have to make sure that we have the same number of each one of these atoms on each side of the equation. So you can see right now that hydrogen has two on both sides, so that's good, that's okay. But oxygen has two on one side and one atom on the other, and that is not okay. So the problem right now is the oxygen, and we have to fix it. So the question becomes, how do you fix it? What do you do to an equation to make it be okay to make sure that none of the atoms are being created or destroyed. And the answer to that is that you balance it. And the way that you balance it is you use something that's called a coefficient. So a coefficient is basically a number that you put in front of a compound, never inside of a compound, always in front of a compound. It's a full-sized number that would go in front of a compound. You can never, ever, ever put it in the middle of a compound. That is not okay to do. They can only go in front. So right now what's happening, and then when you put it in front, you multiply the number of atoms in that compound by the number. So we've got 2 oxygen atoms on the reactant side. We have 1 oxygen atom on the product side. We need to have 2 oxygen atoms over here. So there's 1 oxygen atom in the compound. We need to multiply that compound by 2. And when we multiply the compound by 2, we multiply the number of oxygen atoms by 2. And you have to look up here at the equation. You can't necessarily look down here. I'll show you why in a second. So there's 1 oxygen atom in this compound times 2. That's going to turn into 2 oxygen atoms. Bam, 2. And now the oxygen is the same on both sides, so it's balanced. However, you have to multiply everything in the compound by 2. If you put a coefficient of 2 in front of a compound, you multiply every atom inside of that compound by 2. So there are 2 hydrogen atoms times 2. That becomes 4. Which means that we are now not balanced because there's 4 hydrogen atoms on this side and there's 2 on this side. But that's an easy enough fix. Can you see how we will fix that? We're going to use another coefficient. We're going to put another number out in front of a compound over here on the reactant side. We have 2 hydrogen atoms already. We need 4, so 2 times 2 is 4. So we're going to put a coefficient of 2 in front of the hydrogen compound, and then the number of hydrogen atoms on this side becomes 4. And then it's the same on both sides. And so then the hydrogens are balanced. And because coefficients only apply to the compound that they're directly in front of, the 2 just applies to the hydrogen and it doesn't apply to the oxygen. The plus sign separates the 2 compounds. And so then this equation is balanced. It's balanced now. So the balanced form of our water equation is 2H2 plus O2 yields 2H2O. And that's how you balance equations. You use the same method no matter what the equation is like. There are a few things that might throw you for a loop, so we're going to go through those in part 2 of this video. But that is the why we balance chemical equations and the basic how to balance chemical equations. So if you have any questions about either one of those things, please make sure you ask in class. And as always, thanks for watching.